So
Oh yeah, I tried finding S1 and S2.
do you know induction?
Yeah, like proof the
Okay.
base case.
Yes, and we can prove it at the end by induction, but let's first focus on x0. So look, Sn is what? Is x0 plus 2x1 to 2 to s to 2 to the n minus 1 xn minus 1, right?
Yeah.
So x0 here we have this condition. If you can say n1, it means that 7s1. S1 is x0. It's congruent to 1 mod 2, right?
Yeah.
Because 7 is 1 mod 2, so we can say x0 is 1 mod 2, and because xi's it says are either 0 or 1, so x0 is 1, right?
Yeah.
And then if you consider n2, n3, so try to find we found x0, try to find x1, x2, and x3. Find all these four x's, okay?
X1 equals 1, X2 equals 1, and X3 equals 0.
Exactly. So it is 1, it is 0, it is 1, it is 1, 1, 1, 1, 0. Okay, so let's check. For this one, it is 7x0 plus 2x1 is congruent to 1
Yeah.
not 4. And then x0 is 1, so and 7 is negative 1 mod 4. So we can conclude negative 1 minus 2x1 is congruent to 1 mod 4. So we can conclude 2x1 is congruent to negative 2 mod 4. Then if we divide both sides by 2, we can say x1 is negative 1 mod what?
2.
Yes, and can you tell me if AB is congruent to AC mod M? It is equivalent that B is congruent to C mod what?
GCF of M and A.
M over GCD of
M
M.
over
And because GCD of 2 and 4 is 2, so mod 4 over 2 mod 2. So x1 is 1, right?
Yeah.
Now if you consider n3, 7x0 is 1, 2x1, 4x2 is congruent to 1 mod 8, right? So 7 is negative 1, and we can multiply both sides by negative 1. So 3 plus 4x2 is negative 1, right?
Yeah.
So we can say 4x2 is congruent to negative 4 mod 8. So we can divide again both sides by 4. So x2 is negative 1 mod what?
2.
Exactly. So we can conclude x2 is 1, right?
Yeah.
Now n4, we can consider 7, 1 plus 2, 3 plus 4, 7 plus 8x3 is congruent to 1 mod 16, right?
Yeah.
So here we can say 56. Let's do something. Yeah, we can multiply both sides by 9. By negative 9. And
yes.
negative 63 is mod 16. What mod?
Negative 1.
Is 1. 63 is negative 1. Negative 63 is 1, right?
Oh, yeah.
So we can say it's negative 9, right? Mod 16. Agreed. So if you subtract 7, 8x3 is negative 16, mod 16. So if you divide both sides by 8, x3 is equal to negative 2 mod 2, which is 0. So x3 is 0, right? Now, can you guess which xi's are 0?
3 mod 4.
3 mod 4, yes, it can be, but let's consider something. You calculated x1, x2, x3, now calculate x4, x5, x6. Calculate these three x's, okay?
I got x4 is 1, x5 is 1, x6.
X6 is what?
0.
Exactly. So now let's rewrite them. X0, 1, x1, 1, x2, 1, x3, 0. x4 1, x5 1, x6 0. Can you guess which numbers are 0?
Mod 0 mod 3.
Exactly. And now let's do something. Let's calculate other cases together. For n5, you should say 7 times 7 plus 8, 16x4, right? Is congruent to 1 mod 32. Agreed?
Yeah.
Then for 7, we can multiply first by 5. So it would be 5 times 7 is 35. So it's 3. 7 plus 16x4 is 5, right?
Yeah.
Then we should multiply by 11. So if you multiply by 11, it would be 1. 16x4 is 55. 55 minus 32 is what?
40. I mean, 16. I mean, 13.
Yes,
20.
it's 23, right?
23.
So 16x4 is 16 mod 32, right?
Yes.
So x4 is 1 mod 2, so x4 is 1.
Yeah.
Now for x5, should consider n6. So 7 times 7 plus 16, 23, plus 32x5, right? Is congruent to 1 mod 64, agreed?
Yeah.
Then we can multiply both sides by 9, or negative 9, right?
Yeah.
So it would be negative 9. And here 23, so 32x5 is congruent to negative 32, right?
Yeah.
Then you can divide by 32, and it would be 2. So x5 is 1, right?
Yeah.
Okay, and let me check. X5 is 1, yes. And 7, then 7 times 23 plus this is 55 plus 64x6, right? It's congruent to 1 mod 128, right?
Yeah.
Okay, so here, if we should multiply 7 by what near 128? 128 is what mod 7?
2.
Yes, it's 7 times 158. 8 plus 2. So because it is 2, so we can multiply it by 8. It is not good to multiply by 18. But let's do something. Why it's not good to multiply by 18? Look, it's important because it is even. When you multiply by 18, you will miss some informations. Understood?
Yeah.
But we can, for example, multiply it by 19. If we multiply it by 19, 7 times 19 is what? 133, right?
Yeah. Okay.
19. And 133 is 5, right?
Yeah.
Mod 128. Then you can multiply it by 130 over 5, right? 130 over 5 is 130 over 5 again is even, so let's multiply it by 25, okay? So
Okay.
do you agree it would be negative 3?
Yes.
So it's 19 times 25. Mod 128. 128 mod 3 is what is 11, right?
Yeah.
129 is multiple of 3. Oh, now that's good. So if you multiply by that, it would be negative 129 times 55 plus 64x6 is congruent to 19 times 25 times, I think I made a mistake. 5 is not negative. No. 5 times 25 is 125, it's negative 3. No, that's correct. So this one times 43, right?
Yeah.
And we know that you can add 1 to 8, it is negative. So 55 plus 64x6 is congruent to negative 19 times 25 times 43, right?
Yeah.
Okay, now we can simplify this. You can say it is equal to 5 times 5 times this. It's 215, right?
Yeah.
215 mod 1 to 8, you can subtract 256, right? So it is
Yeah.
negative what? 41, right?
Yeah.
So it would be 19 times 5 times 41. Agreed?
Yes.
5, it is 19. 5 times is 205, right?
Yeah.
205 is what?
77.
Yes, or negative 55. Negative 51, right?
Yeah.
Okay, so here we can do what? We can also do something instead of that, because it is multiple of 5. We can do something. We can say that 64x6 is congruent to 5 times 4 times 19 minus 11. Agreed?
Yeah.
4 times 19 is what?
76.
But here we have one problem. It shouldn't be odd. Look, it is odd. Also, this one should be odd. This one is 41, not 4, right?
Yeah.
Okay, 41. 19 times 41 minus 11, right?
Yes.
19 times 41 is what is 19? 4 times 9, 36, 76. So 977, right? 779 minus 11 is what? 867, right?
7. Yeah.
And if you divide by 64, is 5 times what?
Mm. 1, 2. 12. 16.
Mod 2, right? 0. Agreed, because 768.
Oh, yeah.
If you divide by 64, if there's 164, 2128 times 2. Okay, so we prove x6 is 0. Your solution was different for finding x6?
Yeah, slightly different.
You use what? Your
Instead,
solution was easier. Your solution was easier, or my solution?
I think your solution.
Okay, there are lots of ways that we can try. Let me tell you also one more thing. Let me tell you another way. Look here. If we can get rid of this 7, it would be good, right?
Yeah.
1 is not multiple of 7. If you add 1 to 8, 1 to 9, is it multiple of 7 or not? Not, because 70...
So 126 is multiple of 7.
Okay, so 70, 59, it's not multiple of that. If you add 1 to 8, it would be what? 257, right?
Yeah.
Is it multiple of 7? No, right?
Yeah.
If you add again 1 to 8, it would be what? 8 plus 7, 15, 8, 3, right?
Yes.
385, is it multiple of 7? Yes.
Yeah.
So 55 plus 64, x6. If you divide it by 7, it would be what? 50.
55.
Mod what?
128.
And then 64 x6 is congruent to what?
0.
Do you agree this one also is easier?
Yes.
Okay, look, there are lots of ways. It's good to know all of them to see which of them is better. So we found these things, and you guess, okay, x submultiples of 0 is 0. So the first one, x 2019, is what?
That's 0.
This one is 110, right? So the answer is what?
6.
6. If you want to make sure that it's correct, we should prove it by induction, right?
Yeah.
And do you know here how we can use induction?
Uh, so we could say for uh, n equals 3 to the k, I mean 3k plus 1, it'll equal x k equals 0. And then we do it for k plus 1, and then k
Yes,
equals
our
2 to the
claim
k.
is xn. If 3 divides n and n is at least 3, is 0, otherwise it is 1, right?
Yeah.
And for base case, you can say, okay, n 0, 1, 2, 3, right? You should write them, and then you should consider, okay, for n 0, 1 to 2, 2, for example, n, or for example, k, you know it's correct, you want to prove for k plus 1, okay? Or
Yeah.
until k minus 1 it is correct, it's satisfied, you want to prove k, and k is at least 4, right? Then you
Yeah.
should consider 3 cases. K, if k is 3q, case 2. If k, you should prove here why x3q is 0, right?
Yeah.
If k is 3q plus 1, and here we know it is at least 6 because we proved 3. Here you should prove x3q plus 1 is 1, and we know it is at least what?
Oh, at least 1.
4, because 1 is in
Oh, yeah.
base case. Okay. And k3q plus 2, it is at least what?
5.
And x3q plus 2 is, we should prove it's 1, right? Now let's prove
Yeah.
one of them together, and then you can prove the rest as homework, okay? It is important. This part, especially full solution exam, like what? You want to prove each of them?
The first.
Okay. So try to prove first case by induction first on your own, and then we try together, and then the rest as homework. Okay, so focus on proving this.
Okay.
One hint or want to keep trying?
Hint.
Okay, sure. So we know that for 1 to k minus 1, that's correct, right?
Yeah.
So we should consider n what to find this n 3q plus 1, agreed?
Yeah.
Then 7 times x0 plus 2x1. So we know x0 is 1, right?
Yeah.
So, or we can say x0 plus, let me write first like this, to the 3q minus 1 x3q minus 1 plus 2 to the 3q x3q, right?
Yeah.
It's congruent to 1 mod what?
2 to the 3q plus 1.
Exactly. Okay, so if we consider this part, we know we can write it as 1 plus 2 plus 2 squared plus 2 cubed. 2, let's write 2 3q minus 1, 2 3q, okay? Let's write all of them. Then minus, we don't have 2q, we don't have 2 to the 6, to 2 to the 3q, agreed?
Yeah.
Can you tell me 1 plus r to the m is what?
One over 1 minus r times 1 minus r to the m plus 1.
You can write it also like this or this, right?
Yeah.
Okay, usually when r is greater than 1, we use this. So, can you tell me this part is what?
That would be 2 to the 3q plus 1 minus 1
Finish, over 2
yeah.
minus 1, which is 1, right?
Yeah.
What about this one?
That one would be 2 to the 3q. No. 2 to the 3q plus 3 minus 1 over 7.
Over 7, but minus 1 because it's not started with 1. Right? Because we should start with 1. Agreed?
Oh, yeah.
Yes. Or you can say we factor from 8. It is from 1, 8 squared to 8q minus 1. So it is 8q minus 1 over 7, right?
Yeah.
So 7 times 2 to the 3q plus 1 minus 1. And 7 times this is plus 8 times 8q minus 1, right?
Yeah.
Plus 7 times 2 to the 3q x 3q is 1 mod 2 to the 3q plus 1, right?
Yeah.
Okay, so here, directly we can cancel this. It is 0 because 2 to the 3q plus 1, right?
Yeah.
And also this one is 0 because you multiplied by 8, right?
Yeah.
So minus 7 plus minus 7 minus 8 plus 7 times 2 to the 3q x 3q is 1 mod 2 to the 3q plus 1, right?
Yeah.
So we can say 7 times 2 to the 3q x 3q. It is minus 15. When you take it to right side, 15, so plus 1, 16, right?
Yeah.
But I think we divide it by 4. And it's not possible. I think we had a careless mistake, so let's check here. We said this one is 1, 2 to 3q minus 2 cubed minus 2 to the 6 minus 2 to the 3 cubed plus this one. So this one is 2 to the 3 cubed plus 1 minus 1, 7 times this minus this one, 8 times. It is 8 to the q, 8q minus 1, 8q minus 1 over 7. So when you multiply by, it is not plus. Here it's minus, right?
Yeah.
Because look, it is minus. We have minus here. So it would be plus 8. So 8 minus 7 is 1, right? So this part is 0, right?
Yeah.
And then you can divide by this coefficient. So x3q is 0 mod what?
2.
Yes, because GCD of this and this is 2 to the 3q is 2. So x3q is 0, right?
Yeah.
Okay, so try to prove this one as homework 1 as homework 2, okay?
Okay.